great, but I need you to be in this space with me right now. Does that sound good? I want to remind you a little bit of what we did yesterday. We spent some good quality time. Hold on, I'm bouncing over here to look for my colors. With some colors, right? We looked at the primary colors of light. Remember, we shined those lights up at the front. We talked about the fact that yellow is not a primary color anymore, is it? It is not of light, but it is of pigment. And I think that's kind of where we ended yesterday. Is that right? Okay. So we talked about light. We said that we've got red, green, and blue light. We can make all of the colors of the rainbow from just those three colors of light. And if we combine all three of those colors together, then for sure we're going to get what color? White. Okay. So taking that the other way, we could also write down. So I'm going to write down, Jacob, and you may want to join me in this as well. We could write down that white light is really a combination of all of the wavelengths of the visible spectrum. So white light includes, if you're talking about it in terms of primary colors, you've got your red and your green and your blue. If you're talking about it in terms of the spectrum of the rainbow, you can talk about it in terms of from 400 to 700 nanometers. Okay? White light includes all of those colors of light. The light that comes from our sun is white light, so it's got all of the colors of the rainbow. The light that comes from our fluorescent tubes in the ceiling is white light, so it's got all of the colors of the rainbow as well. All right? All of that light is shining on you all, and the reason that you see me and you see each other is that some of that light, let me say one more thing and then I've got you, okay? That light comes in, it bounces off of a surface, and just like any other wave, guys, we talked about this when we were doing waves last week. When a wave encounters a surface, some of that wave bounces off, and some of it is transmitted in. Remember that? Yes or no? Yeah?
Yes.
Yeah? Okay. So we're going to talk today about what light is transmitted versus what light bounces off. Okay? Yeah.
Why does the sun look yellow?
Because, did I show you guys this graph? I thought I did, but maybe I didn't. Did we look at the radiation curves? Yeah, we looked at this. And so if you look at the intensity spectrum, where is the light most intense, friend?
Yellow.
Hey!
Okay.
That's why. Yeah. Easy answer for you. So that's part of it. The other part of it is that the light also travels through the atmosphere, and some of it gets scattered, but the yellow light, being the most intense, gets through to us the most. Does that make sense? So it's kind of a two-part answer. Yeah?
So you're going to talk about like the difference between like when you mix paints, why that's
Different things happen, right? So we're not going to talk a lot about mixing paint for two reasons. Number one, because we're focused on light right now, right? We're doing light and light waves. That's number one, and the primary reason, I guess. But also because the mixing of paints and mixing of pigments are a little bit different. So when we talk about pigment, I'm going to go back to my my other picture here. I can't remember if we talked about this. I think we did, right? When I said that they print my book or they print any other thing that's printed in color, how many different layers of paint do they use? 3. And what are they? Magenta, yellow, and cyan, right? So there are those 3 layers. Sometimes you may find, like, I think about, like, when I go to the grocery store, sometimes, like, you find a box that has been kind of misprinted, and you'll see the colors are a little bit off. Or another place that I see this sometimes is on, like, a newspaper, like the Sunday paper when it's printed in color, and, like, they didn't quite line it up just right, and so things are a little bit cattywampus. That's a good, like, my grandma kind of word, right? And so you'll have a little bit of extra red over here and a little bit of extra blue over there because it didn't quite get lined up just perfectly, okay? And when that happens, the reason for that, is because the colors, when they were put down, were not put down right on top of one another. Does that kind of make sense? Yeah. So when we talk about mixing pigment, so we could talk about that. If you mix yellow pigment and cyan pigment, what color are you going to get?
Green.
You would. You'd get green pigment, wouldn't you? So yellow pigment and cyan pigment give you green. How about magenta pigment and cyan pigment? It's true, right? Yellow and magenta are going to give you red, okay? And then any other color in there is going, because that would be like equal parts of each, right? But then if you have a little bit of one and a lot of another, then you can get all those colors in the rainbow. You look perplexed there.
So if you mix red and blue together, you get magenta.
Red and blue light.
Yes.
Correct. Red light and blue light together give you magenta. That is true.
And then if you add cyan and turn blue again.
No. Okay. So I love that you asked that question because it actually brings us to kind of where I was going next anyway. So it has to do with whether you're talking about the light or the pigment. Okay? So when we're talking about light, we're adding these things together. Now, I could have a cyan light, right? A light that lets only cyan out. So it'd be like this, except it would be one that was combining green and blue. And if I had that light and I shone the cyan light with the red light, what color am I going to get, friends? I'm going to get white, right? Because red plus cyan equals white. If I have a red light and a magenta light, what's that going to look like? It's going to be reddy magenta-y, right? Like it's not going to change to blue or something like that because it's not subtractive. It's called additive. We're talking about additive colors, okay? We'll talk about the subtractive part in just a minute. Let me take that from you. Yeah. So the subtractive part of it is, this part I think is even more interesting. So let me back up for a second to where I was going at one point. When the white light from our lights shines down and shines on Shahad's shirt, right? Remember that white light has got all of the colors of the spectrum in it. It's got the reds and the orange and yellow, green, blue, indigo, violet, right? What color does her shirt look like to you? It's red, right? That's because the red light from these lights bounces off of her shirt and bounces towards your eyes, to your receptors, okay? What happens to the green light and the blue light?
Absorb.
It's all absorbed in her shirt, okay? Let's look at Zach's shirt. He's got a bright like orangey green, or not, excuse me, yellow green shirt, right? So what color is being reflected by his shirt? Yellowy green, right? That wavelength of light. And the red, and the blue, and the purple, and all those things in that spectrum that are not that color are being what by his shirt? Absorbed. Grace has got a white shirt on. So white light comes in, and what kind of light is being absorbed by her shirt?
None of it.
None of it. None of it, right? What's being reflected? All of the colors of light, right? They're all being reflected back to my eye. We combine them all together, and then we get white. Okay? And then we look at Madeline's shirt, and all that white light is being incident. Either Madeline, you could pick a Madeline, either Madeline, it does not matter. The light comes in, it hits their shirts, and what happens to that light? It's all being absorbed. Okay? We doing okay so far? Because I'm going to throw something funny at your brain next, so I want to make sure that you're okay so far. Yeah? Okay. So here's the next piece. I'm going to share with you a funny effect that I came across a few years ago when I was kind of getting started teaching this stuff. And I have a good friend who is really, really into theater. And she did theater all the way through college and does theater now professionally and all of this. And she's a director. She's not an actress. And we were talking one day about light. And she's like, oh yeah, I totally use that all the time. When they're doing lighting design, they use all this physics they don't maybe say it in the physics terms, but they're doing all this stuff, okay? So I wanted to share this with you. So I was doing all this research, and I came across this article from the New York Times that I can't remember the date, but I'm thinking like 1904 or something like that, like a long time ago. And it was a theater review from this show where they used this new effect that nobody had ever seen before, and it was like magic on stage. And so what happened, according to the article, and this was before they had an opportunity, like they couldn't take pictures or videos, right? So there's no like YouTube video of this because it was a long time ago, okay? But the story goes that there was this woman who was dressed in like this old, or appeared to be dressed in this like old, like witch costume, right? Like you can kind of imagine, like, and looked really like haggard and terrible and whatever. And she stood there. Nothing happened. She did not move, and nothing came across her. Like there was nothing around her. The only thing that happened was that they flipped the lights. That was it. They switched the lights, and the way she appeared changed from like this old, like yucky looking, like mean old to like this grand ball gown princess something. Just because of the light, which seems kind of fishy to me. But then when I was doing some more digging, I was like, oh, well, I mean, like, this is, I'm not going to show you that, but I'm going to show you something that, like, to me seemed pretty convincing of this idea. So I'm going to go ahead and show this to you. The Samolyov effect, I think is how you say that. I don't actually know because I don't speak Russian, and I know this guy was Russian. But if you know better than me, then please tell me because I'd like to learn. All right. So anyway, this is not magic. It's physics. I want to make that very clear because I don't want you to think that we're doing magic because this is all just physics. But we're going to talk through how this all works. And you may want to write down some of this stuff kind of as we go. I'm not going to quiz you on what the guy's name is, though. I just want to make that really clear. All right. So this is a scarf, just like a handkerchief kind of scarf thing. And it's made of 2 different colors of silk. What colors do you see? These stripes are red. Yeah. And what does this kind of look? It's kind of bluish, kind of greenish, maybe. It's kind of turquoise-ish. I would call this cyan. That's what they intended for it to be. And what is cyan a combination of? Just curious to make sure we're all there. Blue and green, right? Okay. And this is under white light. So this is just like, a lamp is turned on, okay? And when this lamp is turned on, this white light lamp, the white light is coming in and it's hitting this red stripe. And what kind of light is being reflected? Red. These are not hard questions, I hope. And when the white comes in and it hits the cyan part of the scarf, what's reflected? Cyan, right? You got the blue and the green. All right, so life is good. Now, same scarf, same picture, different light. So instead of having the white light on, they took a red spotlight. Same deal. Turned it on. What does it look like now? Tell me what you see.
Red.
It looks red? What looks red?
Scarf.
The scarf, the whole thing just looks like a red scarf. One color.
2 different reds.
2 different reds. Maybe your brain, if you look at it and just know that this is under red light, like I tell you, oh, it's under red light. What does it look like to you? What color do you think that scarf is? It could look like what? Yeah, your brain might tell you that this is white and this is black. Does that make sense? If it's under red light, then like a white part is going to just reflect the red, and the black is going to just not reflect anything, and so you wouldn't see that, right? You can kind of see that, and I think that's more from the shine, but this looks like it could be black. It might be white and black. It might also be, what else? What other color could this be? If you know that it's red light, what color could this part be? Red. It could also be red. And this could look black as well. Does that make sense? It doesn't look white at all?
If it's a red light.
If you know that it's a red light shining, because if I take my red light, here? Which one's red here? And I shine it on your shirt. Sorry, I'm not trying to shine your eyes. On your shirt. What color is this shirt? It might be red, it might be white. We don't really know. You with me there? Yeah. So we don't really know. All we know is that it's shining red light. I don't know what color this floor is. It could be white, it could be red. I don't have enough information. Because all I'm shining on it is red. And I know the red is bouncing back. So there's for sure some red in it. But white has red in it also, right? So it could be. We don't know for sure which one it is. Is that making sense? Are we doing okay? Okay. So we're going to do the same thing. Same flag. Same color. Different light. So that's under cyan light. So that means that we've got like a blue filter and a green filter on there at the same time. What does this look like now? This looks black. And what does this look like? It could be white, right? It looks to me like, does that make more sense? Like that looks, sure, like if you just walked up and you say, oh, it's a cyan light, like it could be a white and black flag. Sure, yeah. Or this could be what? If you know it's cyan light, then this could be cyan. So it could be black and cyan. We don't really know yet. Is that kind of making sense? Do you see how this kind of magic can happen, again, just from light? This is the best example. I'm going to show you a couple of more that I like a lot too, but I'm going to erase this real quick so that I can show this other one. This picture cracks me up every time I see it, this next one, mostly because the guy in the middle looks really thrilled to be there. It's like, yeah, it's awesome. So this flag here is the one that we saw before. You just turned it the other way. So this flag here has red stripes, and then what is this? What did we decide? That's cyan. And cyan, we remember, is what plus what? What colors are in this flag?
Yellow.
This part up here is blue. Are you with me there? And what's this part? This part is yellow. That's what it's supposed to be. Yellow is kind of tricky because it's a little bit hard to like make the right color of yellow to make it not look white, right? Yellow is a combination in light of what and what? What is it? Red and green. And then what about this flag over here? So the stripes, the kind of diagonal stripes are green. And if we kind of follow the patterns, blue and yellow, they have a relationship, don't they? Cyan and red, they have a relationship. What are blue and yellow? What kind of colors are they? Remember what those are called? Complementary colors. Cyan and red are complementary colors. This isn't quite red. What is this down here? That is magenta. And magenta is a combination of what and what? Okay. So again, the next set of pictures are not awesome, but you can kind of get a sense of what's going on here. So under blue light, let's take a look at this one. Under blue light. This one's a little bit hard to see, and they kind of got a little bit messed up here. But you can see that under blue light, especially this one here, right? That's the one that we had kind of seen before anyway. The red stripes now have turned almost black. The cyan stripes look what? They look like they could be white, or they could be blue. I mean, this is really blue, right? If you had this in a vacuum, it would look pretty blue to you. This one looks kind of funny. Do you remember what color these were? The corners of that flag?
Blue.
The corners were blue, right? Look at the corners of the flag now. What do they look like? They look blue, I guess, or white. I mean, like, again, this is where our brains start to trick us a little bit. What color is it? Is it blue? Is it white? I don't know. This right here, in actuality, this piece of fabric right here, the corner, is blue. Does it look blue to you?
No.
It does not, because I'm shining a blue light on blue fabric. Blue light on blue fabric gives you blue, but again, our brains are trying to pull that apart, so this may look white. The yellow absorbs all of that blue light. That's why it looks a little bit funny and dark. That one over there is a little hard to see. I'm going to do one more. This next one I like better. Tell me what you see in that first flag and the one on the left.
Red and black.
See red and black. Is this a red and black flag?
No,
No. What are these corners?
blue.
They're blue. These are supposed to be blue. Why do they look black?
Because of the red light.
Because the red light doesn't have any what in it? Doesn't have any blue in it. So all of the red light that's incident on these corners is what? What is it, friends? All of the red light that's incident on these corners, what happens to it? It gets absorbed. It gets sucked in and absorbed. What color is this?
Red.
Looks red. What color is it actually under white light?
Yellow.
It's yellow. But yellow will reflect both green and red, won't it? Is there any green light to be reflected? No green light to be reflected. That means no green light available, so it's just going to look red. This one I think is kind of interesting too. The one on the corner. Because it looks almost the same. All three of these look like they could be the same colors, don't they? Because one's got red and one's not got red. It's very stark. It's very stark. They did blue light, they did red light. Let's look at the green one just for kicks. The blue and yellow one is, I think that the coloring got a little bit messed up. But this one looks very much red or black and white, doesn't it? This one too. It's hard to tell that these two things are made of very different colors. Okay. The lighting can make a huge difference. Makes a huge difference. Yeah.
So then those like primary light colors, do they actually exist or are they just like combinations? Like magenta, is there actual
Like, is there a wavelength that exists for, is that what you're asking? I mean, I feel like the question you're asking me is kind of a philosophical one, but I'm not quite sure. Every color has a wavelength associated with it. So every single color of the whole rainbow, right? They go from 400 to 700 nanometers. So there is a color that's associated with 532 nanometers. And it's a different color than at 533 nanometers, which is different than at 562. You know what I'm saying? Every single color has a different wavelength associated with it. But when we're talking about color and light, generally we think of just these three as the ones that, from these three, you can make all the colors.
So they like get combined?
Correct. Yeah. And when you combine them, so it's the same thing. You guys, this is exactly the same idea as we talked about with constructive and destructive interference. And it's the same thing that we talk about, like, you know, when we're talking about like beats, kind of. You get different colors from different combinations of wavelengths being associated at the same time at the same place. Yeah.
Okay, why wouldn't they like print newspapers and stuff? Do they use like magenta and stuff? Why don't they use the other primary colors?
They use magenta, cyan, and yellow because those are the primary colors of pigment. So if you use red, green, and blue pigment, you can't get all of the colors of pigment because.
Why did we do that in art class? Like,
That's a really good question. Somebody else asked me that too, and they ask me every year, and I know that I need to figure it out. And I have asked art teachers in the past. The trouble is that I need somebody that's not just an artist, because artists are very matter-of-fact, practical people, right? Like, that's just what we use, that's just what we have. There's a color theorist out there that has the answer that I really want. Do you know what I'm saying? Like somebody who really studies color theory. The best answer that I've ever gotten has been that when you are printing, when you print using ink, the way to get color to mix the best is using those three colors. And I think, I'm trying to, because I literally every time I have a new art teacher that I work with, I ask to see, you know, like, because everybody has different experiences. the best answer that I ever received on that was because we've always done it this way. Does that make sense? So before we really combined and got into print media, think about where paints came from, right? They came from natural things, right? And so you would get naturally occurring reds and blues and yellows, right? Does that make sense? But when you actually want all of the pure colors, the best way to get all of the pure colors is to use those three individual colors. Does that kind of make sense? Yeah, it's a totally fair question. And it's weird and it's frustrating because it's not what we're used to. But when, you know, if you go into art and you're actually studying art production, that's what they'll do, is use those three. Yeah. Shahad, did you have a question?
Yeah. So since yellow is like a combination of green and red, if I shined a green
Shown is, it's the word. It's a weird word though, but go ahead. Yeah.
green and red light at the yellow flag, would it absorb both of them? Or
Well,
reflect them?
let's try it, shall we? Can we do it? Okay, hold on just a second. Let me, I'm recording this and they're not gonna be able to see any of that. So let me pause my, before we move on, because we've just done a bunch of stuff and I don't know that you've written down anything. I'm not sure if you've really processed any of this. I'm going to give you just a couple minutes right now to write down what you've seen so that when I ask you these questions on Monday on, I don't know, like a quiz or something, you have a sense of, you know, what we've done. So take just a couple minutes, your pencil and your paper, to write down what you know, what you've figured out.